Hey you guys, today we're going to be doing lesson 2 out of unit 1. It is called rates of change. In topic 1.1, we learned that the phrase rate of change is synonymous with the word slope. So a positive rate of change indicates that a function has a positive slope, meaning that the function is increasing. And a negative rate of change indicates that a function has a negative slope, meaning that the function is decreasing. In AP Precalculus, we will define the rate of change of a function at a point as the rate at which the output values would change if the input values were to change at that point. In AP Precalculus, we are unable to find the rate of change of a function at a given point. This will require calculus. But we need to determine if the rate of change at a given point is positive, negative, or zero. We will also need to be able to compare the rates of change at two distinct points. When considering rates of change at a given point, it may be helpful to think about the graph as a roller coaster. If the car you are riding is going up, then the function has a positive rate of change at that point. If you are going down, the function has a negative rate of change at that point. At the instant point, when you're at the top of a peak or at the bottom of a valley, you are not moving up or down. At this single instant point, you are changing between going up and going down. At these points, the rate of change is neither positive nor negative. The rate of change is zero. Okay, so I want to go back to this part where it says top of the peak or bottom of a valley. In mathematical terms, this would be called your maximum and your minimum. So when you are at a maximum or a minimum, your rate of change is zero because you are not changing directions. You are waiting to either go down or up. Okay, so here we have a diagram of a little roller coaster. You can see the three little carts there. So we have 3 points. We have t sub 1, t sub 2, and t sub 3. So whenever you're trying to find the rate of change at a point, so notice that I have t sub 1 right here. What I'm going to do is draw a line that kind of hugs the curve, but it's still going through the point. So that's different than when you were learning how to do the slope from 2 points, because you might say, okay, from that point to this point, and then you would go like that. So that's with 2 points, but we're doing this with 1 point. So I can see that for t sub 1, my rate of change is going to be positive because my line is going up. I'm going up, right? Now, if you look at t sub 2, this is your maximum. Okay, so you can see that at t sub 2, if I were to draw a line, it's not going up or down. It's just horizontal. That means that my rate of change is 0. Okay, now we look over to the other side where we have t sub 3. If I draw a line that's going through that point, you can see that my line is going down. So I have a negative rate of change. Okay, now if you're trying to figure out which rate of change is the smallest or the greatest, you're going to have some questions that ask you order the rates of change from least to greatest or from greatest to least. Okay, in that case, you would think of a number line, right? Because on a number line, all the way to the left, you have your negative numbers, and all the way to the right, you have your positive numbers, and right in the middle, you have 0. So that means that this negative rate of change is going to be somewhere here. So let's say this is t sub 3, and then let's say this is t sub 2, which had a rate of change of 0, and then a positive rate of change, we would have t sub 1 with the biggest rate of change. So you want to think of it numerically. So a lot of kids think that 0 is the smallest just because it's 0. That's not true. You're thinking numerically on a number line, which number is the smallest? That means that a negative number would be smaller than 0. So off to the side here, I'm just going to write that t sub 3 had the smallest rate of change because it is a negative number. Okay? And then the biggest rate of change would be the positive one. So that means that the 0 is right in the middle. Okay? Now there are going to be some questions that, you have multiple positive ones or several negative ones. So for example, let's say I were to make a third point here and label that t sub 4. Okay? Now if I draw my line at t sub 4, my line looks like this. T sub 4 also has a positive rate of change. So then how could I determine which one is more positive? Because I have this one that goes like this and this one that goes like that. In that instance, you would look at the steepness of the line. So whatever is the steepest means that that's your highest value, okay? And it could be the same thing for a negative. So if I were to add an extra negative one here, let's say I call this one t sub 5, then I would make a line that goes like this, okay? You see how this line is more steep than the other positive one? The t sub 4 looks a little bit more horizontal, while t sub 1 looks more vertical. The vertical one means that it's more steep, meaning that it's bigger. If we're looking at the negative ones, t sub 5 looks more steep than t sub 3. It's very slight, but you can still tell that t sub 5 is going down lower. So if I were, just as an example, to label the order from least to greatest, I would say the smallest one here would be t sub 5 because it is the steepest negative line. And then let's say we would have t sub 3, which is the next negative, and then t sub 2, which is the one at 0. The next biggest would be t sub 4 because it is less steep than t sub 1, which would be your biggest rate of change because it has the steepest line. So there are going to be some questions where they ask you to do that, okay? On the next page, we see an example of this. It says the figure shows the graph of a function f in the xy plane with 3 labeled points. Order the rates of change of f at the 3 labeled points from least to greatest. So the first thing you're going to do is annotate next to your points to indicate whether it's a positive or negative rate of change or if it's 0. So I'm going to look at A and I'm going to make a line that's kind of hugging the curve at the same time, including the point A. And I see that I have a positive rate of change. Okay, I'll say rate of change is positive. Now, if I look at B, I see that I'm going down. So that means I have a negative rate of change. And then if I look at C, this is a minimum value. And remember, minimums and maximums have a rate of change of 0. So this is not going up or down. So I'm going to say rate of change is 0. Okay. So to answer the question, whenever you have a free response, remember that you have to repeat the question or kind of reword it in a way that it's going to make sense. So I see that it says order the rates of change of f. So I'm going to start my answer with saying the rates of change of f. Okay. The rates of change of f at the 3 labeled points ordered from least to greatest are. Okay, so I haven't actually done anything yet. Okay, so the rates of change of f at the 3 labeled points, I wrote that, the rates of change of f at the 3 labeled points, and then I took the word ordered and I put it here, and then I kept going from least to greatest, from least to greatest. Okay, now at the end I'm going to put my answer. Okay, so the smallest rate of change is your negative rate of change, which is B. Then we have 0, which is letter C, and then the positive rate of change will be the biggest rate of change, which is at point A. Okay, let's try another example. The figure shows the graph of a function g in the xy plane with 4 labeled points. Of the following points, at which is the rate of change of g the least? So I'm going to underline this because that's going to be important when we finish. Okay, so now what I'm going to do is start the same process that I did earlier, which is to make my little lines. So here's point A. I can see that this has a positive rate of change. Point B also has a positive rate of change, but you see how the point B, the line is steeper? I already know that B is going to be bigger than A just because this line goes more vertical than this one. Okay, so the more vertical, the bigger the number is there. If I look at C, I'm going down, so I know this is going to have a negative rate of change. And then for point D, same thing, it's going down. So point D has a negative rate of change as well. But if you're looking at C, you can see it's a little bit more horizontal than D. D almost goes straight down, so that lets me know that D is going to be the smallest. Okay, so if I'm going to answer the question, it says of the points which is the least, I can already eliminate A and B because those are positive. Okay, so the least ones are going to be either C or D, which have a negative rate of change. And then, like I just said, the steeper the line, the more negative, the smaller the number is. So since D had a steeper line, that means that D would be the correct answer. So I'm going to say that the graph is steeper at point D. So the rate of change at point D is less than the rate of change at point C. Okay. Moving on to the next page, another important concept that we will use throughout AP Precalculus and AP Calculus is the average rate of change of a function over an interval. The average rate of change of a function over an interval is the constant rate of change that yields the same change in the output values as the function yielded on that interval. It is the ratio of the change in the output values to the change in the input values over that interval. We will look more closely at the average rate of change of a function in topic 1.3, including how to calculate the average rate of change over a given interval. In topic 1.2, we will approach average rates of change in a way that is very similar to how we approach the rate of change at a given point. We will determine if the average rate of change over an interval is positive, negative, or zero, and we will compare the average rates of change over two distinct intervals. Example 3 says, the figure shows the graph of the function y equals h of x. Of the following, on which interval is the average rate of change of h the greatest? So I'm going to underline this so I know what the question is, okay? Now, this is going to be different because in the previous examples, we had points A, B, C, and D. Now we have intervals 2 to 3, 3 to 5, 5 to 7, 7 to 8, okay? And I know these are all intervals including x values because the inequality sign, in between the inequality signs, we all have x. So these are not coordinate points or anything. We're going from x equals 2 to x equals 3, from x equals 3 to x equals 5, etc., etc. So what we're going to do is locate where x equals 2 on here, and I'm going to find the y value. We have a y value right there. So at 2, my y value is 6. So I'm going to annotate 2 comma 6. The next thing I need to find is where x equals 3. And at x equals 3, my y value also equals 6. What that means is that when I went from x equals 2 to x equals 3, I ended up still at y equals 6. So that means that there was no change in the output values. So if there's no change, that means that my rate of change is 0. So for answer choice A, I'm going to put 0 because there's no change in the output values. And just in case you forgot, the output values are your y values. Okay, so because we went from y equals 6 to y equals 6, there was no change in the output values. Now we're going to repeat this process with answer choice B, which goes from 3 to 5. I already have the coordinate point for 3, which I know is at y equals 6. So I'm going to go to x equals 5, and I see that there's a point here. I'm going to approximate that it's at 3.8. It doesn't have to be perfect because all we're trying to figure out is it going up or down? Is my rate of change positive or negative? And I see that to get from 3 to 5, I have to go down. That means that my rate of change is going to be negative. And we're going to say because the output values decrease. Okay, so my y value went from a positive 6 to a 3.8. Let's try that again. Now we're going to do the interval 5 to 7. So if you look at x equals 7, we have a coordinate point at 6. So 7 comma 6. Okay, so to get from 5 to 7, I'm going to have to go up, which means that my rate of change is positive. So I'm going to put here 5 to 7 has a positive rate of change because the output values increase. Okay, and then finally we have 7 to 8. So at x equals 8, I'm going to say 8 comma 4. So to get from 7 to 8, I have to go down, which again means that the rate of change is negative. So from 7 to 8, the rate of change is negative because the output values decrease. Okay, so now that I've made notes for every answer choice, I'm going to go back to the question, which does say which rate of change is the greatest. So there's only one positive, so that means that it has to be C as in cat. Okay, moving on to the next page, we have another example. Example 4 says the graph of the function y equals f of x in the xy plane always has a negative rate of change. Which of the following definitions for the variables x and y would best model the function f? Now, a key word here is that it says always has a negative rate of change. Okay, a negative rate of change is basically a line that has a negative slope. So if I were to draw that scenario, I would expect to see a line that is going down like this. What that means is as your x values increase, because in this direction you're going towards the positive numbers, right? So as your x variable is increasing, your y variable should be decreasing. So when you're looking for a negative rate of change, your two variables should be behaving in opposite ways. So if you have a positive rate of change, both x and y will be both increasing or both decreasing. But for negative, it's going to be opposite. While one increases, the other one decreases. So let's read the options. So for letter A, it says that x is the age in years of a young child and y is the height in inches of the young child. Well, I know that as you get older, you get taller. So both of those are actually moving in a positive direction, right? You get older, you get taller. That's going to be a positive rate of change, and the graph for that will look more like this. So I'm just going to put on here that this has a positive rate of change. Okay? So I know that A cannot be the correct answer. For B, we say the total number of points scored in a basketball game and Y, the time remaining in seconds in the game. Well, I know that as the game goes on, usually basketball players are making points, right? They're scoring baskets. But as the game goes on, the time is running out, right? So when you begin the game, you have a lot of time but no points. And as you progress through the game, your time is counting down, but you should be making more points. So that could be a contender. Let's keep going to see if there's a better choice. For C, we have X, which is the time in seconds since the ball was thrown straight up in the air, and Y, the height in feet of the ball. Now, this does say, has a key word here. It says thrown straight up in the air. So if I were to draw a little graph of that, I know that the ball at first was getting thrown straight up. Well, I know that everything that goes up has to come down, so eventually that ball will come down, right? But what that means is that this can't be the answer because of that rate of change at the front. So this one has a positive rate of change, while this one has a negative rate of change. So C can't be the answer because the question said always has a negative rate of change. And because it said it was getting thrown straight up in the air, I know that for half of that curve, I'm going up. Now, it would be different if they had said, I'm throwing a ball from the top of a building. Then if you're throwing it straight down, then that could be an answer. but because they said I'm throwing it straight up in the air first, C is going to be eliminated. Okay. For D, we have X is the radius in meters of a circle and Y is the area in square inches of the circle. Well, if you think about circles, if you have a small circle with a radius versus a bigger circle with another radius, if your radius is smaller, you're going to have a smaller area. If you have a bigger radius, you're going to have a bigger area. So you see how both of those things are going the same direction? If it's smaller, the area is smaller. If the radius is bigger, your area is bigger. So since X and Y are both increasing or they're both decreasing, this would also be a positive rate of change. So it's going to be going up just like answer choice A was. So this is a positive rate of change, so D cannot be the correct answer. So that means that B is in fact the correct answer because as the number of points is increasing, your time left in the game is decreasing. And I can write that down. Okay, so for answer choice B, we can say as the time left in the game decreases, the number of points scored increases. Okay, so you see how one was decreasing while the other one was increasing. So they need to be opposite in order for it to always have a negative rate of change. Okay, now we have some more examples. For each scenario below, determine whether two quantities typically have a positive rate of change or a negative rate of change and explain why. We kind of already did answer, letter A, a child's age versus the child's height. Earlier, we said that this would have a positive rate of change because as a child's age increases, their height also increases, right? As you get older, you get taller up to a certain point, right? You're not going to grow forever, just until, you're around 18 or 20 years old, you stop growing. For letter B, we have a golfer skill level versus the golfer score. Now, to answer this question correctly, you need to have some familiarity with the technicalities of golf. So in golf, it's different than, like, let's say basketball, soccer, football, any of those other sports where your objective is to make as many points as possible. In golf, your objective is actually to have a low score. So if you think about it, if you think about a golfer hitting the ball, they would much rather have a hole in one. That would show great skill, right? If you hit the club and you hit the ball, and then your first attempt, it goes straight into the hole on the floor. However, if you're not a very good golf player, you're going to take many attempts to try to get the ball in the hole. So for that reason, this is going to have a negative rate of change. Negative rate of change because as a golfer's skill level increases, their score will decrease. And again, I'm just going to put in parentheses, this is better in golf. Okay, so in golf, you do not want a large score. Okay, you don't want to be that player, that's hitting the ball and then it's going all around the grass and then it falls in the sand and then it falls in the water and you're, taking forever. Your objective is to get it into the hole in as little attempts as possible. Okay, now letter C says the height from the ground of a coin dropped from the top of the reunion tower versus the speed of the coin as it falls. Okay, so if we're thinking about the height from the ground, when I'm at the top of the building, the height of the ground right here. Let me draw this. Let's say this is the reunion tower, and let's say this is the ground. When I'm at the top, my distance is really big. But as the coin falls, my height from the ground is decreasing. It's getting smaller and smaller and smaller. Okay, so I already know one of my variables is going down. My height is going down. Now, speed, as a coin falls, is going to gain momentum, and that speed is going to increase. So this one is also going to have a negative rate of change. Because as the height from the ground decreases, the speed of the coin increases. Okay, so again, for negative rates of change, you're going to have opposite variables. So as one increases, the other one decreases. As one decreases, the other one increases. Basically, if they're not the same direction, it's going to be a negative rate of change. Okay, now let's find the average rate of change using a formula. So you might recognize this formula from middle school. You know it as a slope formula. It's y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now I can upgrade this formula a little bit using function notation. So I can say that the average rate of change could also be equal to f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. Now the reason I'm doing this is because we all know that y is equal to f of x, right? So if I want y sub 1, then I need to plug in x sub 1. If I want y sub 2, then I need to plug in x sub 2, okay? So it's the same thing, it's just upgraded a little bit, for the class. So the first step is going to be to find your y values. So they're going to give you an interval. They're going to say from this x value to that x value, find the average rate of change. Using those x values, you're going to figure out what the y values are. After you have the y values, you're going to find the slope between those 2 points using the average rate of change formula, or the same thing, the slope formula. Okay, so here we have 2 examples. Find the average rate of change of the following functions on the given intervals. So for letter A, we have f of x equals negative x cubed plus 3x on the interval negative 2 to negative 1. The first thing I want you to do is label these x sub 1, x sub 2. So your intervals are x values. They are not coordinate points. Please do not say, don't think that that's a point. That is not x comma y. That is saying from x equals negative 2 to x equals negative 1, what is the average rate of change? So now that I have the 2 x values, I need to figure out what my y values are. So if I try to find y sub 1, that means I need to find f of x sub 1. And remember that x sub 1 is negative 2. Okay? So I have 3 different x's here. So that x equals negative 2, I'm going to plug it into all of the x's. So I have negative, and then in parentheses, I'm going to put negative 2 cubed plus 3 times negative 2. Okay, now when you're simplifying this, you do have to follow PEMDAS. So if you think of PEMDAS, parentheses comes first. But in my parentheses, I don't have anything to solve. So I'm going to move on to exponent. I have one exponent, which is negative 2 cubed. Remember that anything cubed is that same number times itself. So I can do negative 2, negative 2, negative 2. If I do these two first, I'm going to get a positive 4. I still have this negative 2. So if you do 4 times negative 2, that's going to be negative 8. Okay? So here I have negative. That negative in the front, I haven't used it, by the way. We have not done anything. This one right here, I'm carrying it down. So we just have negative, and then in parentheses, negative 8 minus 6. Now the 2 negatives in the front are going to make a positive. So this ends up being 8 minus 6, which equals 2. Okay. Now if it helps you to write these as coordinate points, you can. So when you plugged in x sub 1, which was negative 2, you ended up with the y value positive 2. So this is your x sub 1, y sub 1, okay? I'm going to put this in a little cloud there. So I forgot the parentheses, I'm sorry. Okay, so again, when you plugged in x sub 1, so I put this in there, and there, and in there, right? So it's here, here, and here. So I plugged negative 2 into every single x that was given to me in the equation, and then I simplified. After I did all this work, my final answer was 2. And remember that all of this was to find y sub 1, so my y sub 1 was 2. So that's one coordinate point. Okay, now I need to repeat all of those steps and I need to find y sub 2. So to find y sub 2, I need to plug in x sub 2. X sub 2 is negative 1. So now I need to find f of negative 1. So now I'm going to do negative 1 cubed plus 3 times negative 1. Negative 1 cubed, that's going to be negative 1. But notice that negative in the front, I haven't used it. And then in parentheses, negative 1 minus 3. Just like before, two negatives make a positive. So this becomes 1 minus 3, which is negative 2. So now my second point is negative 1, negative 2. And I can label this x sub 2, y sub 2. Okay. Now the final step is to find the average rate of change. So for that, I'm going to use my slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I know that y sub 2 is negative 2, y sub 1 is 2. That is divided by x sub 2, which is negative 1, minus, and then in parentheses, negative 2. Okay, negative 2 minus 2 is negative 4. All right, these two negatives here make a positive. So negative 1 plus 2 becomes 1, and negative 4 over 1 is negative 4. So your final answer for your average rate of change is negative 4. Okay, if you went over a little bit, you can draw a line just to stay organized. Okay, so now let's repeat everything on letter B. So your first step is to label your interval x sub 1, x sub 2. Your next step is to find y sub 1 by plugging in x sub 1, and x sub 1 is positive 1. Okay, on this one I have 3 x's, so we have 1 plus 1 over 1 plus 6, which is 2 over 7. I can't reduce that anymore, so I'm going to move on and find y sub 2. To find that, I need to plug in x sub 2 into the function of h, which would end up being h of 4. If I plug that in, I'm going to have 4 plus 1 over 4 plus 6, which is 5 over 10, which reduces to 1/2. If I take those numbers and find the average rate of change, I'm going to subtract the y values, which are 1/2 minus 2 over 7, and that is being divided by my x values, which is 4 minus 1. Okay, now before I can subtract fractions, I need to make sure I have a common denominator. So because this is 7, I'm going to multiply this fraction by 7 on the top and on the bottom. And because, let me get a different color, this denominator is 2, I'm going to multiply this fraction by 2 on both sides. Okay. So then my fraction becomes 7 over 14 minus 4 over 14. So you cannot subtract until you have the same denominator. And then 4 minus 1, which is 3. Once you have the same denominator, all you do is subtract the numerators. So 7 minus 4 is 3. This is still denominator 14, and all of this is being divided by 3. Okay? To divide, let me make some notes here. So to subtract fractions, you need a common denominator. Okay, so that's the first thing. The second thing, to divide fractions, you're gonna do keep, change, and then flip. So what you're gonna do is you're gonna keep the numerator, which is 3 over 14. After that, you're going to change the sign to multiplication. The next part is to flip. Now 3 is a whole number. It helps to have it as a fraction, so I'm going to put it over 1. If I flip 3 over 1, I get 1/3. Okay? Now from here, those 3's cancel each other out. So my final answer is what's left over, which is 1 over 14. Now, if you don't feel too confident with fractions yet, that's okay. We're going to get a lot of practice in this year, so you don't have to rely on your calculators like you have in the past. Okay, the next page, the graph of g of x is shown below. Find the average rate of change of g of x over the interval -1 to 3. So the first thing you need to do is label your intervals x1, x sub 2. Okay, so this one is more straightforward than when you're given the equation. When you get the equation, you have to solve manually using algebra. But if you're given a graph, you just have to get the coordinate point. So since my first x value is -1, I'm going to find x equals -1, and I see I have a coordinate point at 0. So I'm going to label this point x1, y1. My next x value is 3, so I go to x equals 3, and I see I have a y value at 4. So that's going to be my x sub 2, y sub 2. From here, I can use the average rate of change formula, which again is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My y values, 4 minus 0, divided by my x values, which are 3 minus -1. Okay, 4 minus 0 is 4. Remember that these two negatives are going to make a positive, so that actually becomes 3 plus 1, which is 4. And then any number divided by itself is always 1. Okay? Now, since this was a free response question, technically you are supposed to write a sentence for it. So we can say the average rate of change of g of x over the interval from -1 to 3 is 1. Okay. The last two problems are calculator problems. I know probably you guys don't have Nspires at home. I'm going to show you the steps, and then I highly encourage you to try this in class. Okay. Example 8, the function k is defined by k of x, and they give you the equation 3.16 plus 4.2x minus 0.85x squared for -10 to 10. Which of the following statements about k is correct? So the first thing you're going to do is graph this. So I'm going to open my calculator and I'm going to open up a new graph. In there, I'm going to type the equation 3.16 plus 4.2x minus 0.85x squared. Okay, and then you're going to press enter. Now notice that I can't see the top of my graph, so I'm going to need to zoom out. Now my calculator interface looks different than the handheld calculators we have in the classroom. But what you would do is go to menu and then Windows Zoom and then zoom out. I don't have that because for mine I can just pinch out like you would on a cell phone. But for you, you would do menu zoom and then zoom out. And you want to zoom out until you can see the top of the graph. Okay? So what I want to do is copy this on our notes, just a rough sketch. It doesn't have to be perfect. And I know that it's a parabola that looks something like this. Okay. Now they told me that I'm restricted from -10 to 10. So let's say this is -10, and let's say this is +10. So I'm not going any further than this. Okay, so we can put endpoints here. We are not going all the way to infinity there. Okay. So if you think about the question, they're asking you, does k have a positive rate of change or a negative rate of change, and then over whatever intervals? Positive rate of change means that the graph is going up. Okay. For negative rate of change, that means that your graph is going down. This is talking about your slope. Okay, so before we look at the intervals, let's just figure that out on our own. Okay, now as I go from left to right at the beginning, I can see that my graph, my rate of change is going up. Okay, so over here I have a positive rate of change. After that, at the very top, remember that's called a maximum. Remember that at the maximums, your rate of change is 0. It is a constant line, so rate of change is 0. Okay, and then after the maximum, you have a negative rate of change because it's going down. So in order to actually answer this question, does the graph go up or go down? We need to figure out what the maximum value is, because at that maximum is where we switch from positive to negative. So in order to do that, I'm going to go back to our graph and I'm going to go to Menu, Analyze Graph, and then Maximum. I'm going to get this dashed line that I can move around with my finger. Now the maximum I know is right here. What you do not want to do is put your line right in the middle of the maximum. Rather, you're going to put it a little bit to the left. And then you're going to let it go. And now you get a second line that you can also move. Now notice you want to make sure that your maximum is within the shaded area. You see how as I move it, it's giving me random points, but those are not really the maximum. You want to drag this line all the way over until it stops moving, just to guarantee that you're actually at the maximum with the correct coordinate point, and then you can let it go. So I'm going to put that value 2.47 on my notes. So the maximum is at x equals 2.47. Okay, I can also put that over here. So this is 2.47. I didn't put the y coordinate because all of these intervals are x values. So it's going from -10 to 8 on the x-axis, etc., etc. I can see all of these x's. If I add the y coordinate, it just is going to make it a little bit more confusing. Okay, so what I want to do now is add all these x values approximately where I think they would be. So I already have -10. I could say that maybe 8.348. I'm just going to round it a little bit. Let's say 8.3 is about right there. Okay, the next one is -0.66. Let's say that's about right here, -0.6. And then 5.6 could possibly be around here. Okay, I already have -10. I already have 2.4. And then for the last one, I already have 2.4. And I already have +10. Okay, so now we're ready to analyze the answer choices. So for answer choice A, it says that from -10, I'm going to highlight this is -10 to about 8.8, it has a positive rate of change. Well, that's not true because you can see that within my red lines, I have all three rates of change. I have a positive, negative, and 0 rate of change. So A cannot be true because it's not only positive, it's all of them. For B, we're going from -0.6 to about 5.6. Okay, now the same issue we had in A is also true for B. I have up, 0, and down. The little range is smaller, but it's still showing all three different rates of change, so B cannot be the correct answer. For C, let's say I go from -10 to 2.47. It says K has a negative rate of change. Well, that's not true because there we are going up. It has a positive rate of change. So that leaves answer choice D, which is the correct answer. But let me just show you that from 2.47 to +10, these are all negative Y values. So rate of change is negative. So D is the correct answer there. Okay. Now the last problem is rate of change from a table. So this table gives the life expectancy of US females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest? So what I want you to do first is label your table. Your birth year is going to be your X variable, and the life expectancy is your y variable. Now we're gonna have to do, it's kind of tedious, but we have the calculator, so it's not too bad. We're gonna have to find the average rate of change 4 different times because we have 4 different answer choices with 4 different intervals. So these are all x values, so we can say this is x sub 1 and x sub 2. So what I'm gonna do is go to my table and I'm gonna find where I have those values. So 1800 is x sub 1 and x sub 2, and then this would be y sub 1, y sub 2. So what I'm going to do is to find the average rate of change is subtract my y values, and then I'm going to subtract my x values, which is 1850 minus 1800. Now from here, you can go to your calculator. Now you need to get out of this graph, so you can go to a regular calculator sheet. You're going to open up a fraction, and then you're going to do 46.10 minus 41.24, and then you're going to divide by 1850 minus 1800 and press enter, and you get a decimal. That decimal, I'm going to copy it on my notes. So this is equal to 0.0972. Okay, now we're going to repeat the steps. So now instead of the interval on A, I'm going from 1850 to 1900. So now I'm doing these two sets. So now instead, this is my x sub 1 and my x sub 2, and now this is y sub 1, y sub 2. So for the average rate of change, I'm going to have 53.63 minus 46.10 all over 1900 minus 1850. And then I'm going to go put that in the calculator. Again, open up a fraction. You're going to put 53.63 minus 46.10 all over 1900 minus 1850. And you get the point, the decimal 0.1506. Okay, now it just keeps going like that. So now we're going to do instead 1900 to 1950. So now this is my x sub 1, x sub 2, and my y sub 1, y sub 2. So we're going to do the average rate of change is 70.65 minus 53.63 all over 1950 minus 1900. Okay, and then repeat the process, plug them into the calculator. 70.65 minus 53.63 all over 1950 minus 1900, you get 0.3404. Okay, and one last time, we're going to do 1950 to 2000. So the average rate of change will be 81.83 minus 70.65 all over 2000 minus 1950. Okay, put it into the calculator. 81.83 minus 70.65 divided by 2000 minus 1950. 0.2236. Okay, so now again, the question was, where is the average rate of change the greatest? That would be answer choice C as in cat when we had 0.3. That's bigger than 0.09, 0.1, and 0.2. So yeah, so that concludes lesson 1.2. I hope that this helps you a ton. Let me know if you guys have any questions. Bye.